Hey guys, welcome to the next video on OpenCV tutorial for beginners using Python. In the last video, we have seen how we can perform simple thresholding in OpenCV using Python using various thresholding techniques. So we have used thresh binary inverse, thresh trunc, thresh to zero inverse. So these were all the simple thresholding techniques. Now in these thresholding techniques, we were setting a global value of our threshold. So in this example, for example, here the global value of threshold is 50, here 200, here 127. So we were setting in simple thresholding the global value, and this means that it is same for all the pixels in the image. Now in this video we are going to learn how to use adaptive thresholding. So adaptive thresholding is the method where the threshold value is calculated for the smaller region. So the threshold is not global for every pixel, but it's calculated for a smaller region, and therefore there will be different threshold value for different regions. Now, why do we need this type of adaptive thresholding? So using simple thresholding might not be a good idea in all the conditions. So there might be conditions where the image has different lighting conditions in different regions, and in those cases where the lighting conditions in the images varies from point to point, in those cases we might want to use adaptive thresholding. So as I said, adaptive thresholding calculates the threshold for a smaller region of images. So we get different thresholding values for different regions of the same image, and as a result, adaptive thresholding gives us better results for images with varying illumination. So let me show you the problem with simple thresholding for the image which have different illumination at different regions. So I have this image called sudoku.png which I'm loading using imRead method, and then I'm just showing this image using imShow method. And then let's use the simple thresholding technique, which is thresh binary for this, and we have set the global threshold value of 127 here, and then we will see the result after this threshold is applied to the image. So I'm going to run this program and let's see what happens. So this is our original image, and then this is the result which we got. So in the result you can see when we apply a same global threshold value, some of the region of this image is black and other region of this image is visible, right? So because the image have different illumination value at different regions, that's why we see half of the image which have the good illumination, and we don't see half of the image which doesn't have the better illumination. So in that case, it's a better idea to use adaptive thresholding. So let's see how we can use adaptive thresholding. So here what I'm going to do is I'm going to declare a variable called th2, and then we use cv.adaptive threshold. So this is the method which we are going to use for performing adaptive thresholding, and this takes few arguments. So first is the source. So our source is the image variable. Now the second parameter here is the max value. So the max value is the non-zero value assigned to the pixels for which the condition is satisfied. So in our case, the maximum value which we can provide to a pixel is 255, and we cannot go more than that, right? Now the third parameter here is the adaptive method. So this adaptive method is going to decide how the thresholding value is calculated, and there are two types of adaptive methods which we can use. So the first method is called cv2.adaptive thresh mean C. So what is the meaning of this adaptive thresh mean underscore C? So using this method, the threshold value is the mean of the neighborhood area. And here is the documentation of these two methods. So adaptive thresh mean C gives us the threshold value using this function, and this is going to give us the mean of the block size multiplied by block size neighborhood of x comma y minus C, which is the constant. And the second adaptive threshold type is this one, which is adaptive thresh Gaussian underscore C. And in this adaptive thresholding, the threshold value is the weighted sum of neighborhood values where weights are the Gaussian window. So let's use the first adaptive method, which is the adaptive thresh mean underscore C. Now the next parameter here is the threshold type. So the threshold type which we are going to use is the thresh binary, which we have also seen in the last video also. And then the next value is the block size. So block size decides the size of the neighborhood area. So here we are going to give the block size 11, and the next parameter here is the value of C. So we have seen that we need to give the value of C also when we use the adaptive thresh mean C and adaptive thresh Gaussian C. So this is the value of C which we are going to give, and C is just a constant which is subtracted from the mean in the case of this adaptive thresh mean method, or the weighted mean in the case of Gaussian adaptive threshold. Okay, so constant we are going to give here is 2, and now what we are going to do is we are going to just load this image which we got after applying this adaptive thresholding, and let's just comment the other window. So we will just see the original image and the adaptive thresholding result. So I'm going to run this code, and you can see the original image here and the result of adaptive thresholding, which looks much better than the simple thresholding technique. So let's uncomment this also. So I'm going to uncomment this, so we will see all the three results at the same time. So this is the original image, and you can see the simple thresholding gives us this value using the global threshold of 127, and adaptive thresholding gives us this value or this image which is much more readable than the simple thresholding technique image. So this is how you can use adaptive thresh mean C method. In a same way, we are going to use the other adaptive thresholding technique, which is called adaptive thresh Gaussian C. So instead of this, we are going to use adaptive thresh Gaussian C, and then all the parameters we are going to leave as same, and let's load the result of this type of thresholding, which is stored in th3. So let's run this code and let's see what happens. So we have already seen this image, which is the simple thresholding. This is the result of the adaptive thresholding mean C, and this is the result of adaptive thresholding Gaussian underscore C. So both of the result looks good because the adaptive thresholding algorithm calculates the thresholding value for different regions. So the thresholding value is not global for each and every pixel of the image. And we have seen the two adaptive methods which are available in adaptive thresholding. So in this way, you can use adaptive thresholding in OpenCV using Python. I hope you have enjoyed this video, and I will see you in the next video.